So today we're going to take a moment to talk about real number sets. Anyone remember, do any of these terms seem familiar from 7th grade math at all?
Nope.
Irrational numbers, natural numbers, whole numbers. Yeah, okay, good. So this should be review. Let's start. Okay. Before we even start, this is going to be confusing. Okay, so just try and stay with me. We're gonna do an Ed puzzle right after this. That's gonna show things a lot more visually, so that it hopefully helps connect the dots a little bit. But we're gonna start with the innermost circle. Okay, my innermost circle here is natural numbers. Okay, natural numbers. These are the numbers that you would naturally start counting with. If I told you to start counting, like Darius, start counting, go. Perfect, where did you start? 1. And then you said 2 and 3, and eventually you'd get up to 20 and every number after that, right? Darius didn't start with 0 when I told him to count, right? Darius didn't start with -10, -9, -8 when I told him to count. So natural numbers start with 1, just like how you naturally start counting. There's not a whole lot to write here, so it's going to take a lot of listening and focus to understand this. Natural numbers are the smallest group of numbers. They only include numbers like 1, 2, 3, 4, 5, 6, 7. No fractions, no decimals, no negatives, and not 0. The next largest subset of numbers is called whole numbers. Whole numbers are all of the natural numbers, 1, 2, 3, 4, 5, 6, 7, and so on, plus 0. So the only difference between a natural number and a whole number is 0. You're not ever going to really need to know natural numbers. Whole numbers, though, very important for us to know. The way that we can remember this is because the number 0 looks like a hole, right? It's like a donut, or I don't know. You know what I mean? Yeah. So 0 is considered a whole number, but it is not considered a natural number. Something like 3 is a natural number, and it's also a whole number. You guys see what I mean by that?
Yeah.
It's like how a square is a rectangle, but a rectangle is not a square. 0 is a natural number as well as a whole number. No, sorry. 0 is a whole number, but not a natural number. See, this is why it gets confusing. I confuse myself. The next biggest subset is integers. I'm going to be honest, I didn't really know how to describe what an integer was until I was like 22. So it will take a while. But an integer includes all the natural numbers, all the whole numbers, plus their negative versions. Okay? One way that I like to think about integers, because I'm a football fan, what are the first 3 letters of integers? INT. And in football, what's an INT? Interception. If you're a quarterback and you throw an interception, is that a good thing or a bad thing? That's a bad thing. So integers include negative numbers. If you throw an interception, that is a negative play. If you have no idea what I'm talking about, hopefully you can just understand that integers include negatives. That's the big difference between an integer and a whole number. Okay? Interceptions are a negative thing in football from an offensive perspective. It's a good thing if you're on defense, but I digress. And outside of integers, we have Rational numbers. Now, this is where things start to get dicey. Rational numbers could be a whole range of different things. Now, rational numbers is a much larger box than the others because they include a lot more different numbers. It includes all the natural numbers. It includes 0, our whole number. It includes all of our negatives as integers. But it also includes partial numbers, like fractions, decimals, negative fractions, and repeating decimals. This is important. Repeating decimals. The way that we can describe rational numbers is all of the above, like we said, plus any number that can be written as a fraction of 2 integers. And what does that mean? Well, 27 over 4, that's written as a fraction. 27 is an integer, and 4 is an integer. So 27 over 4 is rational. Now you may see a repeating decimal like this, 0.33333 forever, and think, oh, that looks irrational. But how can we write 0.33333 as a fraction? As a fraction. You're super close. The 3 is going to be under, and 1 is going to be on top. Right? 1 over 3, if you plug that into a calculator, you get 0.33333 forever. 1 divided by 3 gives me 0.3333333 forever and ever, right? That's what this little bar on top means. So because we can write this repeating decimal as a fraction of 2 integers, it's considered rational. If this is kind of making sense, kind of not making sense, don't worry, that's understandable, okay? We'll take our time. Now let's say we have a number that doesn't fall in any of these categories. That would be, what number? Oh, great. An irrational number. I also like to call irrational numbers ugly numbers because they're ugly. Ugly numbers. Something like the square root of 2, which we know from yesterday's lesson, that cannot be simplified anymore. There's nothing we can break 2 up into. If we put the square root of 2 into a calculator, we get some very ugly number. Right? This is not a repeating decimal, just a bunch of digits in no particular order. Anyone know what this little symbol represents? Pi. What's pi equal to? 3.14159.265.389, blah, 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 something like that. Did I get it right? Nope, whatever. Doesn't matter. 3.14159.265.389. Oh, I was right, because 3/8 rounds up to 4. So, very long number, lots of ugly digits, irrational number. Negative square roots that can't be broken up either. If I have the negative square root of 11, again, very ugly number. And if you look at this decimal, that's the ugliest number of them all. Whole bunch of stuff going on. If I told you to write 3.23466876573 as a fraction, you would not be able to do that. There's no pattern here. It's not as easy as 1/3 and 0.33. This cannot be written as a fraction, making it irrational. Okay, if you look down, that's the difference. Irrational numbers are any number that cannot be written as a fraction of 2 integers. Now this is the easiest one for us to know. Real numbers include all rational and irrational numbers. Every number we work with in this class, I promise you, will be considered a real number. And you may be going, Mr. Church, if there's a real number, is there a fake number? There is. It's called an imaginary number. And you won't have to worry about that for a couple of years, thankfully. So everything we talk about in this class will be a real number, whether it's ugly or not. They're all real numbers. Okay? I know that's a lot, and I know it's confusing, and I know a lot of that stuff sounds the same. But those are all real number sets. See you later. Have a good rest of your day. Okay? So this is a there's a lot going on over here. We're going to take a look at all these numbers and figure out which categories they fall into. Okay, we're going to do some of these together, and then we're going to run out of time. Okay. Right off the bat, my first column is real. Right? Are any of these numbers imaginary numbers? No. Like I said, every number we look at in this class is a real number. So let's cross out all those. They are all real numbers. We're not even going to worry about imaginary numbers until we're old enough to drive a car. Okay. But these other categories we do have to think about and break down. So, this is a bad one to start with, but if I have negative square root of 16, let's think about this for a second. What is the square root of 16? 4. So the negative square root of 16 is equal to negative 4. If we look over here, which category would negative 4 fall into, just by looking at all these different boxes?
Integers.
Integers, great. There's my negative 4. So we know that it's an integer. We know that it's a rational number, but we're not going to go into these smaller categories. Negative 4 is not a whole number and not a natural number. But everything larger than that, we're going to include. So integers, rational, and real. Integer, rational, real. It's not a whole number, not a natural number, and definitely not an irrational number. Give me a thumbs up if you see how we figured out which categories that one falls into. Good. A couple people here, a couple people there. Okay. What about 4? Let's take a look here. Where would 4 fall under?
Natural numbers.
Natural numbers. Good. I heard someone say whole numbers. That's absolutely right. 4 would be a natural number. That's one of the numbers that you would naturally count to if I asked you to start counting. So we're in the innermost circle, which means we're including all the outermost circles as well. Natural, whole, integer, rational, and real. Natural, whole, integer, rational, real. The only category 4 does not fall into is irrational. Let me take a look at the next one, negative 5. Much like negative 4, right? Negative 5 and negative 4 fall under the same umbrella. So what categories can we cross off here for negative 5? Integer and what? Rational. This next one's interesting. We've got 1 over 2. Which category would that fraction 1/2 fall under? Rational, that's right. Our fractions are over here. They are not integers. They are not whole numbers. They are not natural numbers. They're just rational and real. Real and rational. Okay, this is the last one we're going to talk about. 2.33333 repeating forever. Where would that fall under? Rational again. Repeating decimals. Rational number. All right. And actually, last one, square root of 3. Even though it's a real number, can we simplify the square root of 3 at all? Nope. Irrational. And nothing else. All right.